My name is Felix. I'm leading the technical development at Cow Protocol, and I'm here to talk or question more so the direction that we are currently taking, maybe as an Ethereum community, asking the question of, does Ethereum really need PBS, or are there other solutions to what we think is a fundamental problem, MEV, and can it be solved only at the infrastructure layer, or can it be solved at the app layer? Before I start, I want to give a brief history of how we got to the point that we are now with the discussion about enshrining PBS and basically really committing to infrastructure solutions to this problem of MEV. And my history starts in November 2020, when a research collective around Phil Dayan and his PhD colleagues at Cornell and some other researchers in the space founded a research collective that was called Flashbots, and that coined this term, which became very influential in the Ethereum ecosystem, MEV. And the goal of Flashbots was really to hit the problem of MEV head-on and tackle it via three main kind of goals: to illuminate, distribute, and democratize access to MEV. But let's first maybe look at what MEV stands for. I think a lot of people know the acronym. It stands for basically any value that can be extracted from the party that produces a block on a blockchain by deciding the ordering of transactions within that block. The most simple example is if you're minting an NFT and there's a limited number of them, let's say 100, but there's 200 people who want to get that NFT, and you're the proposer who creates the next block. It's up to you to decide who of the 200 participants actually ends up getting that NFT. And if you're a big NFT fan yourself, you might even include your transaction first to make sure you get the very first version of it. And so the first thing that Flashbots did was illuminate what they would call the dark forest, the games that were being played in the public mempool around transaction ordering and the value that was extracted from users by doing so. They created a number of transparency dashboards. This one is one of the more recent ones that only captures the value extracted since the merge, but that basically showed how much of a problem MEV really is. It's $1 billion a year kind of value that's being extracted, and at least the data that we see here is a lower bound because there's a lot of value and communication that are not actually visible on chain. So the true MEV that's being extracted is likely an order of magnitude more, and that doesn't even take into account all the MEV that would be created if we got a lot more users on chain. And at least in our mind, solving MEV is a prerequisite of getting 1 million more users on chain, because if there's no safe and secure ways to make sure you're not being taken advantage of, you will reside to other solutions. But let's go back on the timeline. It is 2021. After illuminating the dark forest, Flashbots went on to democratize access to MEV by creating a client, which was basically a fork of Geth that they called MEV Geth, and which gave block producers, which were called miners at the time, a way of communicating with another party for the extraction of that MEV, and that party was called a searcher. Miners were traditionally very good at getting access to cheap hardware, cheap electricity, but they were not DeFi deegans that would understand the underlying protocols and optimize kind of the games and strategies you could do in reordering, including or censoring transactions in meaningful ways. What MEV Geth basically was now an auction protocol that would allow the block producer to kind of sell off the right for proposing the correct, the most value extracted version of the block to an external party, the searchers, and basically have an auction for the searcher that bids the most for what they would call a bundle, just an ordering of transaction, end up getting their bundle included on chain. We can see here that MEV Geth basically created a huge amount of extra revenue for the miners that opted into this system, an order of magnitude larger block rewards if you were a participant in that MEV Geth protocol and you used the extra revenue from the MEV, versus if you were just sorting transactions the vanilla way that Geth would do. And so MEV Geth found a lot of adoption. I think just before the merge, it was around 90% of blocks on proof-of-work Ethereum were produced using MEV Geth. And this was somehow kind of possible and easy because proof-of-work was very centralized. There's only roughly five or a handful of different mining pools that were producing the largest part of blocks, and all that kind of, this Flashbots had to do was to convince those 5 mining pools to adopt MEV Geth, and basically they could reasonably do so because there were so few of them. However, one of the fundamental problems of the MEV-Geth approach in proof of work was that there was a trust assumption inherent to the auction. The searcher would not be able to just reveal the bundles that they have found kind of straight to the miner and say, here's the MEV that I found, please go and extract it, I will pay you 50% of it, because in that case, the miner could have just taken that bundle, replaced the transaction of the searcher, put in their own address, and taken 100% of that value. Now, this kind of trust assumption is inherent to this new, you have searchers, you have block producers, but it was not such a problem in proof of work because the block production process was such a repetitive game. If there's only 5 entities creating blocks, and it means like every minute you are creating a new block, if you were to violate that trust assumption now just to get maybe 1 or 2 more ETH in the current block, you would lose up all the revenue in the future blocks because no searcher would reveal their content to you anymore. However, in proof of stake, our vision was that we would get on to many, many different solo stakers, each of which would maybe produce a new block once every 4 months. And so that trust assumption and that repetitive game, that violating trust in one round of the game would sacrifice your entire revenue for the future, is much more of a big problem if all you really get is 1 block every 4 months. And so I guess if we hadn't thought about PBS, or if we hadn't introduced PBS at the time, what would have happened is Flashbots would have gone to the big staking pool, got them involved into continuing to do the MEV stuff and working with searchers, and the solo stakers would have kind of been left out because you cannot really trust them, but that would have led to significant centralization on the validator parts. Big mining pools or big staking pools would be able to get more revenue, and so they would be able to accrue more and more stake, centralizing the protocol further. So what the Ethereum Foundation and also Vitalik's post kind of suggested was that we split the task of creating consensus around what is the next block, kind of more on a high level, what is the block header and attesting and validating blocks, to this core decentralized solo staking incentive capable group of people, and have another task that is more specialized, more complex, which is actually creating the full contents of the block, which transactions go into what slot, to a different party, which would be called the builders. So we can keep proposers highly decentralized. There's no advantage in being a big staking pool or a solo staker, as long as you opt into this, again, auction system where builders kind of propose blocks that you would adopt, and you as a validator only have to take the highest bid and not worry about finding any arbitrage or finding any other MEV yourself. So, this is great system and great in theory, and also Flashbots agreed to adopt this system and basically build a proprietary version of PBS, which they called MEV Boost. MEV Boost got huge success in the first 3 months after the merge, and I think today about 95% of blocks are built using this version of PBS. However, the fundamental trust assumption that we had in MEV-Geth and that we're trying to also somehow model with PBS remains, is that the builder or whoever finds the MEV cannot just simply give out the blueprint and trust the proposer that they will not unbundle the block or change some of the blueprint for themselves. But at the same time, the proposer can also not just say, hey, builder, just give me a block header and I will attest to it, because if the proposer attests to a block that's invalid or doesn't actually get revealed at the end, they also lose out opportunity cost and potentially even get slashed in the proof of stake protocol. So one of the core components in PBS is this middle layer, the so-called relay, which bridges that gap and again takes something that is maybe not so repetitive in the game, like a proposer only validating a block every 4 months, and makes it a very repetitive game. Builders will not submit their block blueprints to a relay if a relay starts leaking the content of the block blueprints, and proposers will not request blocks from relays that have been known to give them invalid blocks or blocks that end up not getting revealed on chain later. And so we ended up again with this somewhat central component that involves trust, and now the idea of enshrining PBS is to basically apply the fundamental theorem of blockchain engineering, which says that, well, any problem can be solved by just introduction of another consensus committee, and basically try to put that relay into the core layer by virtue of adding a new consensus committee. I don't think this version of PBS is final yet. I also don't want to go too much into the the details of how it works under the hood, but basically you will have then the validators, which are fully decentralized, attesting to the block headers, and then you'll have another committee and the builders who are responsible for revealing the block content separately. But needless to say, adding another committee adds complexity to the chain, and it's not even clear that enshrined PBS will be adopted, because whenever you try to build something into a peer-to-peer layer, you're taking some trade-offs which you don't have in the existing system. Some advanced features of relays today are, for instance, builder bid cancellations. So if a builder changes their mind and doesn't want to pay 10 ETH for the block anymore, but only 9 ETH, they can do this today. And also more advanced co-location techniques where you're trying to really shave off milliseconds of latency by being very close to the relay or very close to the builder are things that just simply do not work in a fully peer-to-peer system. So even if we enshrine PBS into the base layer, it's not clear that big builders and large staking pools will adopt this as the only way of producing blocks. So the question that I want to ask is it worth to add all this complexity, or is there not another way of how we can address MEV? And I think one slide that I actually also wanted to just briefly mention, one of the kind of obvious drawbacks of this proposer-builder separation is, well, it keeps the proposer layer very decentralized. We have 1 million validators that are proposing blocks, but if the thing that's really important about blocks on Ethereum is what's inside them, and if the entities that decide on the contents of the block are just 3 that create here, I think, more than 90% of today's blocks, and 2 of them, for instance, apply some semi-questionable censoring decisions to the contents of their blocks, then how decentralized is Ethereum really? Like how much value is there in having decentralized block header production if the block content production is highly centralized? Okay, so this was my rant. Let's now go and try to find an alternative on how we can solve this. Before we do so, I want to go through a few more types of MEV that are kind of at the core of this problem and contributing to most of the value that is being leaked today. The first one you probably all know, swap MEV, commonly known as sandwich, front-running, back-run. If you go on a MEV-aware block explorer like this one, Zero MEV, and look up a trade that you may have done in the past on Uniswap or some other kind of traditional AMM, you might find yourself in what is known as a sandwich, which basically you have someone that is labeled as the miner, so it might be the searcher or the builder, that ends up trading the same asset that you're buying, coincidentally just in front of you, driving the price up. Then your trade gets included at a higher price than you would maybe originally expect, and then that same entity is selling the asset at the higher price because you just drove the price up even higher and makes a risk-free profit. Swap MEV is the most detrimental MEV to the average retail user, but not the largest MEV in terms of absolute cost or absolute kind of value leakage. The largest is actually the arbitrage that happens between centralized and decentralized exchanges, which is also commonly known as LVR, loss versus rebalancing. And it stems from the fact that centralized exchanges move at a much faster pace than the Ethereum blockchain. Binance has a trading model of continuous time, so the price on Binance updates kind of always, whereas the price of a Uniswap pool, for instance, on Ethereum can only update every 12 seconds when there's a new block. And so now let's say that the price of Binance went up, and the price of Uniswap stayed untouched for the last 12 seconds. Whoever now gets the first slot in the block and can grab that outdated liquidity from the Uniswap pool at, I think, $2,800 here, can turn around to Binance, sell it for $2,810, and make a risk-free profit. That difference is called loss versus rebalancing, and it's basically a cost, a tax that is paid for by the liquidity provider that contributes funds to Uniswap. You can see this type of MEV usually at the top of the block. There are many minor transactions that are buying the same asset kind of on different pools, trying to sweep in all the outdated liquidity at outdated prices and paying a hefty tip to the proposer to get the right to be included in the first slots of the block. We also have liquidations. If you have an Aave or Maker position and your collateral becomes worth less, then the protocol might trigger a permissionless liquidation where anyone can buy the debt from you and pay back the debt on your behalf to seize your collateral, which again creates some MEV because there's usually a premium for doing so, and so people are racing to be just behind the Oracle update, which got your position underwater. There's two more types of MEV, which by and large are negligible in terms of frequency or size. So I don't want to go much more into detail here. The thing that I want to do is I want to slice MEV by a dimension which I would consider DEX-related MEV and non-DEX-related MEV. And what we've done here is we've looked at the transactions that are not found in the public mempool, but ended up on chain. So these are transactions that have been communicated directly between searchers, builders, block producers, and those are an indicator of kind of MEV transactions that try to kind of have a preference on how they are ordered. And if we then look at how much of those, this is the value that they produce. If we look at how much of those transactions are involving some kind of DEX trade, and how many are not, we can see that MEV is vastly, vastly dominated by DEX-related transactions. So if we can get rid of DEX-related MEV, my argument is we get rid of a large chunk of the MEV. Even the non-DEX-related MEV on this slide is partially could be considered somewhat trading-related because NFTs are taken out of here, and even some of the liquidations are not accounted for. And so if we can solve DEX MEV, we are basically reducing the amount of MEV by an order of magnitude. Okay, so let's try to solve DEX MEV, and for that I want to first recap the root cause and kind of what do all these points that I had before have in common. The fundamental flaw that I think we've been doing in dApp design for the last 5 years, or basically since Ethereum is around, is that we've built DeFi mechanisms on the false promise of continuous time. If you trade on Ethereum, if two people trade on Uniswap in the same block, those two people will get different prices. So we are in this spot now where there's only some amount of information getting revealed every 12 seconds, and the ordering of how transactions are ordered in the block that gets revealed is up to whoever produces this block, yet we have the same asset inside the same block trade at many different prices. Here we have the most liquid asset, ETHUSD, trading at 1% difference within the same block. And this basically allows the block producer to look at all the different trades that are in there and say, okay, I'm going to create a transaction that buys at the lowest price and sells at the highest price and make a risk-free profit. Really, to me, that's kind of the fundamental root cause of MEV, or DEX MEV at least, is the fact that the same asset in the same block can have many prices. So how do we solve this? I have to speedrun this solution. It's basically what's implemented in Cow Protocol. I'm happy to talk more in detail also afterwards. But basically, first, what we have to do is we have to break kind of the sequential processing of transaction that is inherent to the Ethereum protocol. So instead of having people say, I'm sending this transaction touching this Uniswap pool, and that's my trade, we need people to sign limit orders, or how they are now called, intents, that say, I just want to buy some Ether, and at the best price, but I don't care which pool you're using. Because that then allows us to batch all those trade intents together into one big settlement transaction, which, together with all the other liquidity we can find on-chain, we can solve for. So you can think of this as like a market with demand and supply, and we're trying to find a solution that kind of settles demand and supply, but it adheres to one simple rule. Every token just has a single price per batch. So if you're trading Ether and I'm trading Ether, and we end up in the same batch, we're getting settled at exactly the same price. Because there's no time priority, there's no concept of who came first, who came second in Ethereum, it doesn't make sense to have different prices. Now, finding such a clearing can be a very computationally complex task. In fact, it can be intractable for larger problem sizes. So what we need to do is we need to decentralize that solution finding off to a network of what we call solvers, which can try to find solution candidates for our batch auction problem and report it back to the protocol. The protocol then scores those candidates based on a goodness criteria, which we call surplus, and picks or allows the solver that proposed the best solution to settle the trade. So how does this protect from MEV? I mean, basically, this is what we built with CowSwap or Cow Protocol, or at least the design has been heavily influenced by this fundamental idea. And it provides MEV protection for a variety of MEV causes that we saw on the previous slide. First of all, it protects users from swap MEV. In the very simple sense, even if you're just looking at intent-based systems like Uniswap X or 1inch Fusion, one thing that those intent-based systems allow is they allow you as a user to just say, I want to buy Ether, and I don't care where, which makes it much harder for a searcher that's trying to manipulate the price on a specific AMM to target your trade and, well, basically manipulate the price. Because instead of just having to address one Uniswap pool that you picked before, they now have to kind of manipulate the entire liquidity that they can find on chain. More importantly, by being agnostic to the exact route that your trade is taking, we can do some more optimized things like deciding to not actually match you against an AMM, but instead match you against another user that also wants to trade at the same time. This is what we call coincidence of wants, short COW. It's where the protocol takes its name from. And the idea is that if you want to buy Ether in the same batch as I want to sell it, then why do we need to pay liquidity provision fees, price impact, and all this stuff? Why don't we just trade peer-to-peer? But even if we cannot find a coincidence of want inside the batch, maybe the solver knows that, oh, this person is buying a very liquid token. There might not be a counterparty right in this settlement here, but I'm sure in the next 5 minutes somebody will show up and take the other side. So a solver might just take some private inventory risk and market make your swap against you, and you don't have to touch an AMM and therefore are not exposed to MEV risk. But even if your token is illiquid and you end up just swapping it, the best route is just ending up swapping it on Uniswap. It's not you who's taking the MEV risk who has to defend themselves against sandwiches, maybe use a private mempool or do whatever more sophisticated entities in this space would do. It's the solver that has bid for the execution who is now responsible for delivering that execution to you. Solvers are sophisticated entities, so they can protect themselves from the risks of the public mempool much better than users can, and we've abstracted that problem of MEV away from the user. But COW protocol doesn't only solve MEV for DEX traders and swaps. It also solves the much larger problem that we've seen of centralized exchange, decentralized exchange arbitrage. Because if we actually make the liquidity provider part of the batch and also settle the AMM at the new equilibrium price, which, if you remember the slide, was much larger than what Uniswap was in the previous block, then that entire difference, that LVR that currently gets captured by the arbitrageur, but who has to pay 99% to the builder, who has to pay 99% to the validator, gets captured by the liquidity providers and can serve as an additional income on top of LP fees as revenue. So we can really make AMMs much more profitable by making them part of the batch and also having them adhere to uniform price clearing. And CowDAO is working on a product for that, which hopefully will come out soon. Liquidations honestly can also be solved in this kind of model. At the end of the day, a liquidation is just a conditional stop-loss order where you're willing to sell your collateral once a certain price is hit or it goes below, the asset goes below a certain price. It's not yet done in CowSwap specifically, but we'd love to work with projects to explore also how we can capture liquidation MEV on the app layer rather than on the infrastructure layer. Now, I was talking a little bit about centralization of PBS and the builder infrastructure before. Of course, one of the questions we get asked also a lot, well, isn't COW protocol also going to get centralized? And there are a few centralization risks. I think the most obvious one is, well, if the builder market is centralized, how do we make sure the solver market doesn't centralize in the same way? Well, we have been using, or the DAO has been using COW protocol's tokenomics to incentivize a more heterogeneous and diverse set of solvers to operate by not simply giving just rewards to the winning solver, but also giving some what's called consistency rewards and making sure that we have a good coverage of competition on kind of the token pairs that people care about. And now the clicker died. But the other centralization risk is, well, whenever you have an auction, you might also have a need for some auctioneer. The thing that you saw on PBS, it was called Relay. But I think that for CowSwap, what we actually need as an auctioneer is just a data availability solution. We need to agree on what are the orders that were valid when a batch was kind of released to the solvers, and then we need data availability on all the solutions that were kind of proposed by solvers and which one is the best. And even if we end up creating a lot of complexity, I think it will be simpler to build this than enshrining PBS. But even if we just need another consensus committee and also apply the fundamental theorem of blockchain engineering, then at least that complexity is localized to the DEX use case and doesn't affect general transfers or all the other applications that we'll hopefully be able to build on Ethereum that don't involve decentralized trading. And with that, I want to close and ask you to join us on the mission to fix the underlying mechanisms and not kind of work towards more complex infrastructure and load the base layer with all that complexity. And yeah, basically, thank you very much.